And I'll give it a minute anyway, because it's still 28 minutes past.
Yeah, just getting the live stream going.
Okay, I see.
I'm pointing at the Pinwheel Galaxy just now, but it's still not dark enough to get decent pictures.
No.
10 seconds and it's starting to look a bit white.
I think it's about 9:10. It gets dark tonight, something like that.
Right, but at least I'm pointing at it, and the guidings might be improving down to 1.4 arc seconds.
Oh, well.
Right. Have you departed, Mark?
He looks like he might have, yeah.
Somebody stole the moon.
Well, you keep talking, it's behind you, Peter.
Oh, no, is it?
Yeah, that's not the pinwheel behind you.
Hello, Mark.
But it's some galaxy, I know that.
Aye. Triangulum.
For those people who are joining us on YouTube, we've lost the moon for the moment. And hopefully Mark is working to get it back on the telescope. Welcome, if you're joining us, to the Astronomical Society of Edinburgh's involvement in the International Observe the Moon Night, and at least it's a clear night. If you're interested at all in the Society, then you'll find a lot more about us on our website. If you go to astronomyedinburgh.org, that will give you lots of information about us. Tonight, though, Mark was, and hopefully will be, showing a view through his telescope on the western edge of Edinburgh, looking at the moon. Hopefully we can see a few of its features. Mark will also probably run through one of the two technical aspects of how he's doing it, and how he controls his telescope. And maybe later on we can have a look at some deep sky objects. We maybe look at some nebula. We maybe see Andromeda, possibly Saturn. It's fair to say, though, that the moon is very low at the moment. And when it's low, you get a lot of atmospheric disturbance. So it can get a bit wobbly, or it can be clear. It can drift in and out. So we'll do our best to give you the as good a shot as we can get, assuming we can reconnect.
Okay, I am back now. Hopefully we can
right.
hear that. Just let me. It was my internet just disappeared. How's that?
There
Good.
we go.
Yay.
So that's the view through your telescope, Mark. And what sort of telescope is it?
It's a 10-inch Newtonian reflector, 4.8, and it's got a CMOS camera on it. Okay, so we can, I think everything's working now. We can have a look at around some of the features on the moon. The first thing I'll do before we start looking is I'll introduce you to something called the ASC 24. These are 24 objects for beginners into astronomy, some of the best views of the sky. And we'll be looking through some of these tonight. And some of these are actually on the moon here. So we'll go through some of the more obvious features on the moon. Back. So as we can see, the darker areas are the lunar seas. And these are large lava seas from ancient volcanic eruptions. So over on the right-hand side here, we've got Mare Crisium. Up here, we've got Mare Serenitatis, and this is the famous Sea of Tranquility, where the Apollo 11 rocket landed, lunar module, and they landed somewhere down at the bottom down here where the mouse is pointing now. Over here is a more interesting area. This is the Mare Imbrium, and there are some interesting objects round about there that we'll have a look at in a minute. You can also see there are quite a lot of ray craters. So over here you can see there's been a big impact and the rays go all over the moon. One down here, this is Tycho, and you can see the rays from that going that way. And also at the bottom down here, another impact crater, which is very bright. They tend to stand out quite well. Let's move into some of the other features. Bear with me while I zoom in. Too much. It is a bit fuzzy tonight because the moon really is low down. So here on the left is a big large crater called Copernicus, which is a really very beautiful crater. Tonight it's very fuzzy, but if I was to bring this one up here, this is what it could look like if it was much higher in the sky and you take an image of it and process it. And it's a very interesting crater with a central peak here. You see lots of good shadows on it because the terminator is not very far away. So the left-hand side here is illuminated by the sun, and the right-hand side is in shadow.
And this is an image you've taken, Matt?
It is through this very telescope, yeah. And here you can see some mountain ranges. So this is the start here of the Apennine mountain range. Let's go back and have a look at that if we can. So you can see that coming here. That's the Apennine Mountains. Up at the top here is the crater Plato. It's quite a really nice, wide, flat crater. These mountains around about it are the Lunar Alps. And you can have a picture of that. So that's just a slightly better view of the Apennine Mountains. And here's a better view of the crater Plato. And these are, as I said, are the Lunar Alps, and you can see a valley actually going through the Lunar Alps there. That's called the Lunar Alpine Valley. And there are various pretty high mountains sitting out in this sea here. And you can see them really nicely illuminated by the sun with the shadow behind it as well. So lots of interesting features at this phase of the moon if it was higher in the sky. And hopefully we'll actually do another live stream when the moon is higher in the sky in Scotland. The International Observe the Moon Night is designed so that people in the north and southern hemisphere can do it at the same night. The problem is, for people as far north of us as us, it's pretty low in the sky. So maybe we'll do our own moon night.
We also said, Mark, that we'd look to try and do a Mars night as well.
Absolutely, yeah. Mars is brilliant at the moment. Really good. Bring down the brightness a little. So quite a lot of detail at the top of the north pole of the moon there, and also at the bottom, quite a lot of detail. And it's a very innocuous looking crater that's called Plato, but if you look at that at full moon, you realize it's actually the source of many of the rays that come out all over the moon.
It's Tycho, isn't it?
It is Tycho, yeah, that's right, yeah, Tycho, yeah. And down here is another very interesting crater called Clavius. Sorry, I said Clavius, it was Tycho, that one, yeah. Clavius is also really interesting. I can find a picture of that for you. No, I have that one. Yeah. Here we go. Here are 4 interesting features on the moon. So there was Plato, there's Copernicus, here is Clavius, which is quite a large flat crater. So the difference, as you can see, is the moon is low down and it's really fuzzy. You can see it's moving all over the place. It's not the best night at all for doing it. This crater on the right here, next to Mare Crisium, is right. It's called Proclass. You can see it's a ray crater, but the rays only come out on one side of it. On the left-hand side here, there's nothing. So either the surface down here was formed after the impact, or more likely, the impact came into quite a sharp, a shallow angle and only shot the ejector out in that direction. Again, quite interesting. And this little crater here is obviously firing ejector all the way across the sea here, Mare Serenitatis. So lots of interesting things to see. At this phase of the moon, you can see a lot of the craters, a lot of the really bright craters. These are where the sun is illuminating them very, very brightly, not many shadows in them. If it was a better night, I could actually show you how to take some of these sorts of pictures from the moon and how to process them to get them really nice and sharp, but it's not worth it tonight. It's much too dark, much too low down in the sky. So this is International Observed Moon Night, so I'll zoom around the moon for a little bit longer, and then we'll go and have a look at some other more interesting objects that are higher in the sky that we can see. The south part of the moon is very, very highly cratered, much different to the central parts and the northern parts as well.
It's certainly sharper than what it was. Right.
It is, yeah, it is. But not very sharp. Anyone care to name this crater at the end of the Apennine Mountains? Can't remember what it's called. Is it?
I think the answer is no.
I think it's Eratosthenes. I've had to consult my lunar atlas. It is, it's Eratosthenes, yeah.
Well, I'm impressed, Mark. Yeah, it's definitely getting hazy now.
It is, yeah. Well, that's International Observe the Moon Night for the moon. I think we should move on to some other things now that might be a bit more interesting. So I'll just zoom into that.
So we may find that Mark has to do some fiddling around. The picture may change and wobble before we get it back again, but it's all part of the fun.
Something like that.
Mark, just a question. You get a lot of the definition where it's between the dark and the light. If you wanted to watch that sort of move across the whole of the moon, how long are you looking at? Do you have to watch it for a month? Is it?
Yeah, the shadow. It's basically from new moon to older moon. So it is a lunar month from one side to the other. I think, yeah. which is what, 28 days, is it?
Yeah.
Horse? Like that, yeah.
So a picture a day, you could do the march of the Terminator right across.
You can, yeah. And the Terminator is an interesting part because that's where the shadows are. So that's basically lunar morning, where the sun's overhead. It's obviously lunar midday and so on. Yeah.
Very optimistic that you've managed to get 28 days in a row.
At the moment, I can't see it at all. It's too low. So yeah.
It's only just emerged from the trees and behind the telegraph pole for me as well. So, okay, I'm going to try and go to Saturn. There'll be a bit of noise while everything moves. I'll mute myself a bit.
You'll be glad to know it's totally thick cloud down here in the south, as you can probably see in the picture behind me. So,
again, for those guests joining us on YouTube, Saturn and Jupiter are fairly low down at the moment, so they're not at their best for viewing. Still, we take what we can get, and they're still fascinating to see. Mars is much higher, and I think if you wait till later in the evening when we've finished, I think it's probably around, is it the southeast tonight around 10 o'clock? It's fairly high. Oh, yes. I see Saturn.
Yep, so there we have Saturn. I'm not going to zoom in too much more because that also is really low down. It's just slightly higher than the moon. You can see it's got rings. I think that's about as much as we're going to get from Saturn tonight. But it's always an amazing thing to see through an eyepiece. I'm going to reduce the ROI and get a better frame rate. I lost it.
Yeah. I think we have a year or two to wait, haven't we, till it becomes higher in the sky?
Yeah. Next year is also not great, but the year after that, Jupiter particularly should be much higher in the sky and better placed.
I think,
Interesting
I think the next couple of years, the rings unfortunately won't be so open. They'll start to close a bit. In 21 and 22, I think they're not quite as open aspect as they are at the moment.
Yeah, yeah. Mars, of course, this year is the one to look at. Forget Jupiter and Saturn this year. Have a look at Mars. It's beautiful. I think if I'm quick, I can get Jupiter before it goes behind the house. Also very low down, so give me a second. Let's see if we can see the moons anyway. Yay!
Yes, yeah, just met them out.
Anyone care to name them? Which ones they are?
Not tonight.
Hi, folks. The one on the left of the planet is Ganymede. The next one on the right is Io, and then the one further out on the right is Europa. Callisto is further away on the left.
Okay, let's see if we can see that one. Oh yeah, there we go, over there.
Well, that's very faint.
There.
Yeah.
Just about.
Oh, yes.
I don't think we're going to see much on the surface of the clouds of Jupiter tonight, this low level. Maybe make it just one belt, I'm not sure. Very high. Very, very low down.
Yeah, yeah.
We'll make do with the moons, I think.
What's your view about the next item?
Right, let's do some proper live stacking. Let's go up to, well, actually, I would quite like to see Albario, actually, the double star. To be careful to make that go the right way as well, because it's the wrong side of the meridian. So I'll just reset a few things. Give me a moment.
Yep. So there's Albario.
Very nice.
Yeah. For those people who have not seen this through an eyepiece, it's stunning, the difference in colour between the two main objects you can see. It's a sort of orangey yellow for the star on the right and a blue for the star on the left. Now tell me, Alan, are they close, or is one just a lot further away from the other? They just appear next to one another.
It's a good question. I think the consensus now is that they're not truly related, that they're just a chance alignment, because the relative motions are too great for them to have if they were in orbit around each other.
Right.
So it's thought that they're, I think it's now considered that they're two separate stars, not gravitationally linked together.
Right. Is it true that they're doubles?
Well, obviously Albario is still a double star. It's not to be, if they were gravitationally linked, they'd be a binary star. It's thought that it's not a binary star. It is a double star. Are the individual stars double or binary? I'm not sure. I can find out for you. But I'd be cheating. I can't. Well, cheat, says Julian. Right, here we go.
I think there's an article on their website about it. Actually, I wrote it a year or so ago when it was finally proven that they aren't really linked at all. So I think there's something there anyway.
Right, the brighter one is a binary.
Right.
Discovered only in 1976. Two stars about 40 times further apart than the Earth is from the Sun, and they orbit each other in about 100 years in an eccentric orbit. And they're 0.4 of an arcsecond apart. Let's look at the Albario B, which is the fainter star. There is no indication that that is double or binary, rather.
Excellent.
Okay, I'm going to move on to something else now.
What's the sort of separation of those two stars we're seeing there at the moment?
Well, this is the point. If they're not gravitationally linked, they could be many light years apart and just happen to be in line.
Yeah, but just visually, you're saying
Oh,
it's,
you mean
it's a binary of 0.4 arc seconds.
Oh, yeah. How far apart are the two stars in angle size on the sky? The gap there is 35 arc seconds across, which is a bit less than the diameter of that Jupiter had currently. 35 arc seconds.
Yeah, you move when you're ready, Mark.
Okay. I'll show people what I actually use to control the telescope while we're at it. So here's the planetarium program I use, Cartesian CL. I just pick an object. I'm going to pick M15, a globular cluster next. And I'm going to say go to it, which means clicking on that button there. And I also use something called EQ mod, which is the telescope control system. So this is the interface between the planetarium program and the telescope itself. It's all pretty neat stuff, all free software. So I'm going to go to M15, a globular cluster in Pegasus.
We can see all your hefty counterweights moving.
Sorry, the noise is the dome moving. It's quite noisy.
I don't have that problem, Mark.
Bit of WD-40 needed there, Mark.
Excuse me while I fiddle around a bit and get this centered.
It's already looking better than my pictures do, Mark.
Okay, I'm going to do something now called live stacking, which means I'll take a series of short exposures. Let's do 10 seconds exposures, and the software is going to automatically stack them and build up a nice image if I get it right. It's now taking the first image. It'll look horrible to start with, but as we keep adding more frames, it should get better. There we go. I'll keep adjusting the histogram until it looks about right.
So, the statistics on this then. Anybody want to venture any?
Is that a question for me?
Well, no, anybody.
I'm a bit caught up with doing stuff at the moment. That'd be great. Thank you. Yeah.
It's 33,000. Going to Sky Safari, it's 33,600 light years away. It's got a central black hole, which is interesting. And it's let's see, diameter of 175 light years. And the brightest star in the cluster is magnitude 12.6.
Okay.
The whole cluster is magnitude 6.2, so you'll see it as a fuzzy, a small fuzzy blob through binoculars.
Yeah. And how many stars are we talking about there?
Oh, good question. I'm not sure I know. It's one of the most densely packed clusters that we know of. In other words, it's quite concentrated, but the blurb here doesn't tell me how many stars is in it. I don't think.
There are about 150 globular clusters that we know of in a halo surrounding our galaxy, though, so they're not in the plane of our galaxy. They're all surrounding it in the sort of sphere.
Most of them are a few 100,000 stars.
Yeah.
So these are the controls I'm using here to do the live stacking. It's stacked 13 frames. It's stacked a total of 2 minutes, 22 seconds. And as I adjust the histogram, it changes the brightness and colors and so on. It's quite a neat way of doing things. Almost real-time astronomy, or at least 10 seconds delayed anyway.
Looking really good, Mark. Really good.
Yeah, it's nice. I like globular clusters. Other people find them boring. I think they're great.
I'm saying nothing.
I was going to do the dumbbell, but it's crossed a meridian, and I don't want to do a meridian flip because it.
Okay.
But I'm actually going to try and do it because I can do something to stop it doing a flip. So give me a second. I'll try that one. A bit tricky. We'll see it.
It's fair to say that anybody who's not seen a globular cluster, that's a good representation of one. And in some cases, you'll struggle to see the difference between some other globular clusters.
Okay, let me try and find the dumbbell. I think it was there, wasn't it, somewhere?
It was, yeah.
Live stack it again. I should say that the camera being used for this is actually cooled to minus 15 degrees C. That helps to keep the noise down. As you can see, there's a lot of noise in that single frame. There'd be a lot more noise if it wasn't cooled as well. And as we stack it, that noise will disappear. We'll get less anyway.
Just a quick question with the cooled CCD cameras, Mark. Is that cooled previous to using it, or is that being currently cooled at present now?
It's being continuously cooled all the time, yeah.
Okay,
Yeah.
cool.
Get it down to minus 15 and it keeps it there for the duration, yeah.
Excellent. And does it try and sort of keep it at the temp you set? Or?
Yeah, it is. It's sort of set point cooling, it's called. So you set the temperature and it keeps it.
Well, that's beginning to look very impressive, Mark.
Looks fantastic. Wonderful.
That's just with 60 seconds of stacking that.
I must admit, I didn't know imaging could be so easy.
The sky is actually still slightly bright, so there's a bit of sky glow you can see at the back as well. It's not quite dark enough.
I just think you're being picky now, Mark.
But you can see the noise in the background is going quite well now.
I'd be pretty proud to have taken a picture like that. I can't believe you just did it in about 30 seconds. That was neat.
Yeah. Take the snapshot, there you go. I'll send it to you.
I thought he was just going to take one with his smartphone there, Mark.
Maybe. Right, let's go and look at something else, shall we? The obvious one to go and look at, it's going to be quite tricky to do because it's quite large, is the Andromeda Galaxy. It's not going to look so good live stack because of its bright central core, but we'll give it a shot. So I'll stop the live stacking.
Does anybody want to say what the dumbbell is?
Oh yeah.
I was waiting for you to ask. It's what they call a planetary nebula. It's the region of gas that was emitted from the central star. You can see right in the middle is a star. It's actually a white dwarf star, the remains of the star that ejected its atmosphere. And that's putting out lots of UV light, and that's energizing the gas that it threw off. So it's glowing. It's around 1,200 light years away. I think there's a lot of uncertainty about that. And the central star is now about 60% the size of the sun, but very compressed. It's like the remains of the stars. It's not like a supernova when you sometimes get a neutron star. This is a hot, small, white, old star with a surface temperature of 85,000 degrees. And that's emitting ultraviolet, which energizes the gas that it previously threw off at the end of its life. And this is the sort of thing that will happen to the sun in about 5 billion years' time.
Oh, we'll look forward to that.
An observing night for that.
Okay, I'll move on to the Andromeda Galaxy.
Yep.
Have anything you like ready for that?
So you must be loading your mount to almost its full weight, looking at the number of counterweights you have. I've been struggling with my errant mount. So last night I was attempting to take a few images of Andromeda just to check it out. They weren't very good. So I'm going to try again a bit later.
No, I can get another counterweight on there actually, so another couple of telescopes on. Right, that's in the center. Let's do some live stacking on that.
It's still moving, still settling.
Yeah. Backlash. Clear that one. Yep, you're right, it's still settling. Well spotted, Ian.
It's amazing how long they take.
It is, isn't it? There we go. Right, let a few of those come in before we do anything there. It's actually not anywhere like in the center. Let's clear that. Do that one. And that one. There we are, getting there now. I think that was a car headlamp that's just done that to me. I'll clear it again. some certain directions of the car headlamps coming down the road just get it every time. Time to build up a bit. You see it's got a really bright core. Alan, anything you'd like to tell us? We have a satellite trail across the bottom. Very shortly, if Elon Musk has his way, we'll have this total image covered in them.
There's a lot that could be said about the Andromeda Galaxy. It's about 2.5 million light years away. And it was once thought to be a bit bigger than our Milky Way, but there's some evidence that it may actually be smaller in mass than our Milky Way galaxy. But otherwise, it's a spiral galaxy, not dissimilar probably to our Milky Way. Now, there are a couple of satellite galaxies nearby, which I don't see on this image, but and you're beginning to see the dark, one of the dark dust lanes that's going across the image from top left to bottom right. Mark's pointing it out. That's not an absence of stars, but a presence of obscuring dust in the spiral arm of the galaxy.
The image is going really bad for some reason.
Mark, I've got the image that I took last night, which I managed to process. So I can show you that at some point once you're finished doing this.
Yeah, okay, we good, yeah.
31. It's got a pretty bright core as well, obviously.
Yeah.
But there's certainly something to work with there. It's quite interesting.
Yeah. The image is getting gradually worse, actually, as it builds up, isn't it?
Could it be clouds?
Yeah, you're right. A patch has just gone over, I think.
I've got the same here.
This is the difficulty of living in an observatory.
Can't see the outside, that's true.
Yes.
Is there anything else anyone would like to point at, preferably in the eastern side, so I don't have to flip everything to the other side of the meridian?
About the triangle.
I'll give that a shot. That's quite faint, isn't it? I'll give it a go.
Yeah, it's pretty challenging.
It's behind me.
Right, let's have a go at triangle them then, shall we? Just for.
Well, at least it's not far.
It's not far, no, you're right. Let's have a go.
Oh, that far.
Sounded like the dentist.
Nice snack again. Don't know how this one will come out. Nothing really.
I'll be in there somewhere, Mark.
I don't think 11 seconds is enough, really. It's quite a faint one.
I've never ever successfully got it.
You can see where it lies through the absence of stars.
Yeah, I think you might be right. It's quite a faint one. It needs really long exposures.
Yeah, you need a bit longer than 10 anyway.
I'm going to clear that and start again. Give it one more shot and see what happens.
Is the double cluster in Perseus high enough yet for you, Mark?
Yeah, it should be. Not sure I'll fit the whole double cluster in, but yeah, that'll be fine. Right, I'm going to get rid of that because it's not going to work.
I'm encouraged, Mark.
Right, let's go for the double cluster then.
You'll have to forgive me in a minute. I'm going to take leave.
Well, we'll just have to do without you. Are you going to go and do some streaming for us, Andrew?
I'm going to see if I can get it to work, Mark. If it points in the right direction and stays there. That's looking good, Mark.
That looks good, Mark.
Where are they then?
Give me a second, I'll get it centered.
Oh, they don't like that clusters. That's what I was saying. They don't know
They're
if it's
open, they're
clustered
open
as the others.
clusters. No, the other one's called open clusters, as
And the other
opposed
one's
to
globular.
globular clusters.
Okay.
They're quite a nice object through a wide-angled eyepiece.
Well worth a look.
I think Horst should tell us about these. I think these are one of his favourites.
I remember Horst showed me this very first time.
Right. Well, it's the name of my website, so.
Right.
Oh, here they come.
Stars.
That's nice.
Really beautiful double cluster, yeah.
Very nice.
So, Horst, what are all the interesting facts about this double cluster?
I'll leave you to it.
It's not a binary, it's a double. One is, I think, about 3,000 light years further away than the other. Which is not as much as a spiral arm, I think, but it is much more than the size of the clusters. So it's a it's a coincidence.
Right.
Really nice.
Building up, yeah.
And, are they in any way related then? No, they're not, is what you're saying.
No.
These are in the plane of the galaxy, though. They're not like the globulars that are all in a
That's
halo.
right, yeah. Yeah, that's true.
What is the separation between the two main clusters then, in terms of arc seconds?
About half a degree, I would say.
Okay.
Well, same as the moon then, yeah.
Yeah.
I find it odd that both have the names of what should be individual stars. And one is Chi, which is a Greek letter, which is the older way of naming stars. And the other is H, which is, no, it's not a Flamsteed number. It's, I think when they ran out of Greek letters, they sometimes used Latin letters.
And how would you define the edges of them?
Well, it's sometimes difficult to know which star is a member and which isn't. You would have to take spectra and figure out the distances of each star. But you can count stars in little squares and see how does the number of stars decrease as you walk away from the center.
All right.
We could do another. Alan, anything to add on the double cluster?
Only that my sources suggest they're both around the same sort of distance, and not 3,000. They're about 7,000 light years from us. And Tycho Brahe just labeled them as one nebulous star and called that rather than a double cluster. And when Johann Bayer assigned Greek letters, he called the brighter one this Chi. And he also gave the name H to the nearby fainter, for a fainter star nearby. But
the other cluster.
One interesting thing, as I understand it, is that they're both very young clusters. They're not very old. They're much younger, for example, than the Pleiades. And they're only probably no more than 6 million years old.
All right.
Perhaps as young as 3.2 million years. So they're not long since they formed from condensation of cloud of gas and dust in the plane of our galaxy.
It's well inside the lifetime of our planet, isn't it?
Pleiades are just rising at the moment, but they're very low down. I can do another open cluster M34 in Perseus. That's relatively nearby, so I'll give that a shot.
Okay.
Staying nice and clear. That's good. My Skyscope is, well, it's not the Skyscope is doing it. EQ Lord is tracking.
You're taking photos or just?
No, I'm just. This is what I'm trying to get on top of here. PhD.
Okay, let's see what happens on this one. Live stacks.
So who's volunteering to give us chapter and verse on this one then? Alan.
I have to. Okay. 1,400 light years away. About 15 light years across. An estimated age of 200 to 250 million years. So it's perhaps a bit older than Pleiades.
Right.
Much less populous than the Pleiades, and it's around 35 arc minutes wide. So it's wider than the Moon.
All right.
It says. Not sure whether Mark agrees, but.
Yeah, this field of view is just over a degree.
Right.
Size, so.
Yeah.
So were all these, I mean, they're all relatively young stars in these clusters. So were they formed in the spiral arms or spun in, or did they just sit in the middle? Where did they come from?
The stars all formed together, different with different masses, and so the more massive stars are the ones that are shining more brightly. But they all formed in our galaxy, in the plane of our galaxy, from a cloud of gas and dust, the contracting cloud. And the older stars, the bigger stars, the brighter stars, are burning up their fuel more rapidly. But the fainter ones are going to outlive them by a long way, because they last much longer. And eventually, this and most of the other star clusters we see, not the globulars, but most of the open star clusters we see, the stars eventually will disperse. They'll just join the general population of stars around our galaxy. The sun probably formed in a star cluster like this 5 billion years ago, and it's a question as where are the sun's siblings? Can we find stars that formed at the same time as the sun, with the same composition and possibly the same origin? And I don't think they've yet decided, they've yet agreed on whether they've found any of those, of the sun's siblings, as it were.
John, will Gaia be able to backtrack some of this stuff and work out where they've come from and where they're going?
Yes, you'll get lots of there's tons of information on it. Is this the? I'm sorry, I missed a bit. I went and got a cup of tea. Well, what are we on at the moment? Is that the Hyades?
No, we're on M34.
Oh, M34, right.
An open star cluster in Perseus.
Yeah, okay. If you give me a second, I'll show you what Gaia thinks of it.
Can I just ask, in the meantime, the Pleiades famously have this sort of nebulosity in the background that they form from. Do these other clusters, a double cluster and this one, have any sort of nebulosity behind them, or do they not?
I think it's thought at the moment that the nebulosity associated with the Pleiades is not the remains of the gas cloud, of the cloud from which they formed. It just is a region of gas and dust in our galaxy they happen to be moving through at the moment. So it's not the remains. It was always thought, and I said in articles many times in the past, that this is the remains of the material from which they formed, but that's not true, not thought to be true anymore. It's thought it's just a coincidence that they happen to be moving through this mass of dust. They are lighting it up, but they're not the origin of it. And I don't think there's any nebulosity associated with this, with M34, this star cluster.
Yeah, I've just had a look at the Gaia results, and you can actually see that the entire cluster is moving the same way, but not particularly fast. There's no high velocity stars in there. But I don't think without stealing Mark's screen, I can actually show it to you very easily.
Well, we'll just have to believe you, John.
Well, what I can do is put it behind me. All
right. Oh, yeah.
It's not. Ugh. So I'm trying to hold the webcam and look at another image. But there's some very faint blue arrows on there you probably can't see that actually show you the proper motion.
All right. It seems to have some nebulosity, has it? Or is that? No,
it's just overexposure on the. This was a photographic plate, don't forget.
All right. Okay.
And it's been digitized. So the stars, as you can see, have got crosses on them from the supports in the telescope.
All right.
I can probably change to. I don't know if it's. Oh, that's good, isn't it? You get half an image. That's the Sloan Digital Sky Survey, which is obviously a CCD, but obviously it only covered part of it. They didn't get the bottom stripe.
All right.
If you look at the other one, which is a click on there, that's Pan-STAR's version.
Oh, well.
Sorry, I'm showing Mark up, I think, a bit here with these images.
Mark's just waiting to move to his next target.
Can I just add that the motion that going to Sky Safari, this cluster, the spatial motion, the motion through the galaxy of this cluster is similar to that of other clusters, indicating a common origin. One of the other clusters being the Pleiades. So it may be not very far away from where the Pleiades were born at different times.
Well, very good. These arrows I showed you a bit confusing because they're only two-dimensional, and of course you really need to look at the 3D motions.
Yeah.
Which is quite fun because the best way of doing that is you can actually see the Gaia data in 3D if you've got one of these modern 3D headsets. And you can actually pop over there and have a look at the individual stars and see whether the whole cluster's going from the middle.
Oh, well, that'll be interesting.
At least virtually.
Yeah. Well, this is probably the end of the easy objects. We said an hour, so it is International Observe the Moonlight. So she'll send the telescope back again. We'll finish on that.
I haven't got a moon on my pictures.
Test my pointing accuracy.
Those images I just showed are off a program called Aladdin, by the way, that actually has got all the Gaia data in it, or access to all the Gaia data, so you can have great fun with it for hours and hours. And I'm not going to give a talk on it next week either, yet. I've only just finished the previous one.
Yeah, that's right. Well, that's why I asked you, John, because you were obviously on top of the stuff.
Yep. And I've written another one on Gaia since the one I gave you last week for next Friday.
That was a great talk there, John, by the way.
Thank you. The next one's a bit more technical. It's on just the HR diagram for a group I belong to. You sort of used to meet in London, but now we've gone virtual, of course.
That's looking very good, Mark.
Seeing's improved a bit, hasn't it? The look of it.
It's certainly sharper. Were you going to give us a test or something, Mark?
I'll unmute, you'll hear me now. I was going to say that's probably the end. It's International Observe the Moon Night, so we can end on the moon. The moon.
Yes.
Yeah, unless anyone else has anything to say or wants to do.
Where's the Earth shine then, Mark, so you can pass your exam?
I don't think you get too much of that phrase, really, do you?
I suppose you could actually go to the moon. If you went to the moon, you'd get moonshine, wouldn't you? It'd be interesting to see that.
I'll drink it, yeah.
It could be better.
Well, that's great, Mark. Fantastic job. A tour of the night sky.
Yeah. So the images would be a lot better if we weren't doing it like this, but it's a quick way of getting simple images that you can see in real time. So yeah, good fun.
Okay.
Okay. I'm off to image something faint now, I think.
Thanks, Mark. That was
Thank
great.
you. Very interesting.
Yeah, thanks very much, Mark.
Excellent.
Okay,
And
see you.
thank-
Bye.
Thanks, Mark. And just
Right.
on behalf of Andrew, I'd just like to say, thanks for everybody who turned up to watch, and those of you on YouTube. And the Astronautical Society of Edinburgh is open for new members. So, if anybody wants to sign up, we're cheap but great.
Yeah.
It's as good as Andrew could do it.
And as Andrew said, we will be doing some more live streams. The moon when it's maybe higher up, and some more of these, and also Mars in October and November, because Mars is looking really good. Still a bit low just now, but yeah. So keep an eye on the website and our YouTube channel. Okay.
If anyone's interested, NASA TV are just starting their Observe the Moon Night for the next 8 hours, I think it is. You have a look at NASA TV. So
Yeah.
Well, thanks very much, Mark. I must go off.